Good day everyone. So today I'm gonna discuss the problem number 2. So the problem says here that a 600 kilogram hammer of a pile driver is lifted 2 meters above a piling head. What is the change in potential energy? If the hammer is released, what will be its velocity when it strikes the piling? The local acceleration due to gravity is 9.65 meter per second squared. So we are asked that we will find the potential energy and the velocity. So first, let's write down the givens. So mass of 600 kilogram, height of 2 meters, and the gravity acceleration due to gravity is 9.65 meter per second squared. So first, let's find the potential energy. So we know that the formula for potential energy is PE equals mgh. So we're just gonna plug in the values. For m is 600 and for the gravitational acceleration is 9.65. The height is 2 meters. So after using my calculator, I got 11,580 joules. Or you can write it as 11.58 kilojoules. Therefore, the change in potential energy is 11.58 kilojoules. So next is to find the velocity of the hammer before hitting the pile. So we assume that there is no air resistance, so this means that all potential energy will be converted into kinetic energy. So using the law of conservation formula, we write it mgh equals 1 half mv squared. So the masses will cancel out. We will left with gh equals 1 half v squared. So we were asked to find the velocity, so we will derive from this formula. We will get v equals square root of 2gh. So the next thing is we're gonna plug in the values because it's already given. So the gravity is was again 9.65. 65. Oh, I forgot the 2. So 2, then the height of still 2. Okay. So let's multiply all inside the square root. So we'll get, wait, 9.65 times 2 times 2, 38.6. So to get the velocity, we should square root the 38.6. We get 6.21 meter per second. So therefore, the hammer strikes the piling with a velocity of 6.21 meter per second. So in conclusion, we first calculated the hammer's potential energy using the equation PE equals mgh. Then, by applying the law of conservation of energy, we found that the hammer's potential energy was completely converted into kinetic energy as it fell. This allowed us to calculate its impact velocity of 6.21 meters per second. I'm Arnold Sama Jr. from BSME 2B. Thank you, and that concludes my presentation.